Hey, recording is rolling. So it is Monday, January 1st. Yeah, welcome back from the break. Yeah, hope you guys had a really good break. Um, here's uh here's how you guys did on the midterm. Oh, yeah, so awesome job if you are on this list, especially if you have a bus. If you have a bus next to your name, that means you either aced the exam or like almost did, got really close. So actually, you know what? The students who, especially the students with the buses next to their name, uh, I bet those students could actually pass the AP exam right now if they got in front of them. Because we've actually covered six of the seven topics. I got good through that, guys. If your name is anywhere on the list, you're actually probably within striking distance. So we're gonna. I do want to go over this midterm with you guys, and of course we'll do lots of practice throughout the semester, get you guys ready for that exam coming up in May. But I gotta get everybody to take it first. Still, a couple students need to take it. So if you need to do any midterm makeups, those are after school this week in the media center. Now, grades are well, from a teacher's point of view, grades are due on Friday, so we have to have your exam by then. So yeah, if you take it on Friday, it's like an extra layer of yeah, stuff going on behind the scenes. So the sooner you do it, the better. Those are in the media center after school. So awesome job if you were on that list. Okay. Actually, let me get back to this later. It's more all right, so let's do a big picture. What's going on? Oh, yeah. Let me hit this real fast. An announcement about school stuff going on. So tomorrow there is testing for all 9th and 10th graders. I know there's a handful of 10th graders in here. So sorry if you're going to be missing class, but the rest of us got to move on and do stuff. But you guys know I always record these, so I'll throw everything on the Google Classroom just like always. Okay. So I did post all the relocation information on Google Classrooms. Again, there's a few 10th graders. Make sure you know where you're supposed to be tomorrow for testing. You're testing your first 3 or 4 classes tomorrow. Okay. So sorry for getting this class post, but that's what we got going on. So if you're 10th grade, check that relocation tech. Okay. All right. So here's a big picture of where we are in the year. We're of course halfway through this year. Okay. So first semester we did measurement, algebra, trigonometry, just like the groundwork for this class. Unit 1 was kinematic motion, which was both linear motion and projectiles. Okay. Unit 2 was dynamics, talking about forces, Newton's laws of motion, that thing. Okay. Unit 3 was this combination of things. There was centripetal force, right, spin things in a circle, circular motion. We combined that with universal gravitation to create orbits. Some of that. Unit 4 was energy conservation, right? Closed systems, open systems, right? Closed systems, open systems also applies to Unit 5 momentum, which anytime you see a collision, think about momentum being conserved, right? Okay. And then we skipped Unit 6. We're about to start on that today, right? And then did Unit 7, which was rotational dynamics. Now, rotational dynamics was like all of this stuff times 2 because there was some rotational equivalent to everything that we did in linear motion, right? Okay. So there's only one topic left by AP's book. They used to do a few more topics, but they cut them in the intervening years. So we just got to do harmonic motion, which is like pendulums, and also if you put a block on a spring and watch it oscillate back and forth, anything's like oscillating. Okay. So we'll take next couple weeks to do that, and then most of the rest of the semester, we're just going to do review, practice exams, FRQs. I'll give you guys some review quizzes. I'm thinking I want to switch to do these more like in class, right? Because I started doing take-home quizzes when the pandemic hit, just because like half the class was at home anyway. And the AP scores ended up being all right after all. And I was kind of surprised about that. But they really, actually, I even had one student who was an e-learner, never saw his face in class, who got a 5 on the exam. So, you just learned just by all the videos. So okay, well, I'll just keep doing this. So this works out. Last year, the scores actually dropped off. I don't know exactly why. So I'm trying to do some new different things this year. I'm looking at these take-home quizzes, thinking, yeah, that might be a factor. So I'm thinking to probably have quizzes in class. So might do some of those. Okay. Now, my other classes, conceptual honors, are study a bunch of topics. Some of these used to be on the AP exam, so I'll keep you guys in touch with what's going on here. But we're not going to do like full focus on this. I'm not going to quiz you guys on any of this stuff. Things like waves, thermodynamics, materials, optics, electricity, DC circuits. DC circuits will probably take at least a couple of days to do with you guys. Magnetism, induction, relativity, quantum mechanics. I might do more with you guys maybe after the AP exam, because we'll have a few days. Okay. What's going on there? All right, new assignment stuff. So you guys, AP, have a couple things going on. AP Classroom, Unit 6, multiple choice. That's been open for a few days. Let's have that. Oh, Where's my due date on that? I have a, oh, here we go. Let's have that due. You guys know that next Monday is Martin Luther King Day, right? So there's no school this coming Monday, right? So I think I'm going to go with this guys on Tuesday, right? And of course we'll have a few days leading up to that. Go over the content with you guys, right? And then chapter 13 puzzles from your guys' textbook. I printed out for you guys. Actually, start with the ones that I want you guys to focus on and do and turn in. Okay, so it's there. Okay. You should have either picked up one of these or have it on your desk. If you don't, then let me know. I've got the copies. Right. Right. You guys good so far? All right. All right. So today's stuff. I got a lab lined up for you guys today. Of course, you guys are in teams, and you guys each have a ring stand and some materials at your desk. All right. So since we're doing harmonic motion, let's just do a classic pendulum. Now, classic pendulum, we're talking about, I've got a mass, sometimes called a bob, on the end of a string. And a string, usually if there's a problem that involves the same thing, they'll specify the string has negligible mass, right? So that all the mass is down here in the bob, right? Okay. Okay. So let's say you pull this back, it's some starting angle, theta, from the vertical, right? You let it swing back and forth, okay? And you can time how much time it takes to swing back and forth, right? You guys brought your cell phone stopwatches today, right? You guys got your cell phones up, right? It's your stopwatches, right? So I'm looking at 4 variables that we could be juggling around that are somehow connected to each other, right? The mass of the bob here, the length of the pendulum, right? The starting angle, and the time period. Now, capital T, every once in a while, I use that to represent tension, but I usually try to use F sub T, like tension force. So capital T, I've been trying to reserve for time period, right? Which is what we have today, right? But careful about the context for capital T, right? Okay. All right. Oh, hey, what do you think time period refers to? Do you think it's the time from here to here? Or do you think it's the time from here back and forth? What do you guys think? Back and forth? Yeah, one full cycle, right? To get back to where it started. So go from here back to where it started is one full time period. Okay, guys get that? Okay. And so there's the question: what's the relationship among those 4 variables? Now, of course, you guys have done plenty of experiments, at least in this class, that you guys know that ideally, if you can strip it down to just 2 of those variables at a time, right, and leave the other 2 controlled, right, you can have a controlled experiment, right? So I've got you guys split up into here. Let's do this. Do you guys see a playing card on your desk? Right, maybe stuff in the string, right? If you have a part. I want you guys to test the time period as a function of the mass. So you'll change out the masses, treat the mass as an independent variable, right? And then time period, treat that sort of like the dependent variable, but you'll control the length and the starting angle. So if you pull it back to like 15 degrees and just keep doing 15 degrees over and over. Also, AP makes a deal about, they like to keep the angle small. So if you specify like 15 degrees or less in an FRT, that might pick you up a point. If you have a diamond card on your desk, I want you to test this relationship, the time period versus the angle. Oh, backtrack a little bit. Let's do a quick hypothesis on this one. Okay, so mass versus time period. So again, controlling for L and controlling for theta. If you increase the mass is more massive, more massive, more massive. What do you think happens to the time period? Let's do a quick hypothesis. There's 3 possibilities. One is that more mass is more time period. More mass could be less time period, which being like faster swing back and forth. And third possibility is maybe mass and time period are independent of each other. So you change out the mass, it's the same time period. Show of hands, how many guys think that more mass is going to correspond to more time? It's going to go slower. Who thinks more mass is going to go faster? And who thinks that more mass is going to leave time period unaffected? Okay, so we got different hypotheses going around. Right. Let's do the diamonds. Right. So if you have a diamond card on your desk, and so you change out this angle. Okay. Now, if you change out the angle, of course, you're leaving L and M constant all throughout. Those are controlled. Okay. So same 3 possibilities, pretty much. Right. So you pull back this angle. Let's say you go from 10 degrees to 20 degrees. Ooh. Right. From the vertical. You guys got protractors on your desk. Right. Might be a good instrument. Right? How many guys think if you increase the angle, it's going to take more time to swing back and forth? Who thinks that? Who thinks if you increase the angle, it's going to be actually faster and take less time to swing back and forth? Okay. And does anybody say the same time period? Right? Make the angle bigger and the time period stays the same. Anybody say that? Okay, we got some votes on that too. Right, so different hypotheses going around. Right, and finally, if you have a spade, you have a spade, do this last experiment where you're leaving the mass and the angle the same, but you're changing out the length of the string. Okay, length of the string. Okay. So same three hypotheses. Let's see what you guys think. How many of you guys think if you increase the length, it's going to take more time to swing back and forth, more time to swing back and forth with longer length? We got some votes there. Who thinks that with a longer pendulum, it'll swing back and forth faster? Maybe less time. Nobody say that? Okay. Does anybody think a longer string would be no relationship with the time period? Anybody think that? No relationship? Okay. Oh, got a couple of votes. All right. And then, of course, you can get more granular with it. So if any of these affect time period, then we can say, like, is it a direct relationship? Like, for example, if you were to double length, would that double the time? Or would it more than double or less than double the time? And okay, just like many past experiments that we've done. Okay. All right, now, once we nail down each of these relationships individually, we can pull everything together in one giant master equation, right? Okay. You guys get the premise there? Okay. All right. Now, I did give you guys this page. You guys got this printed page on your desk. Right. Now, tell you what, this is double-sided. There's another experiment on the back. How the school year is laid out, we're technically still in first semester. I don't want to put any grades in the grade book until the end of this week because it'll mess everything up. So hang on to this page at least for this other lab also. But wait to put these grades in. Right. I gave you guys a table, but you guys know depending on which suit is on your desk, you're going to control two of these variables and treat one of these as independent. Right. Oh, look, I got two columns for time. There's time sub 10 and time sub 1. You guys know what this is about. We've done this several times before. Right? If you let it swing back and forth 10 times, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, okay, and then divide by 10, then you guys know that would, what's the purpose of that? If you were to write it down, reduce random error, right? Right, because that random error of starting stopping the watch is also divided by 10, right? Right. So you get or reduce experimental error, right? This last column, tell you what, let's split this last column in half because I'm thinking of two ways this could go. Right, let me zoom in here. Okay. You could square the time period, which would be have a unit of square seconds. Alternatively, there's another way to go about this. You can take the square root of the length, might be important later on. Be like the square root of centimeters, I guess. Let's have you guys figure centimeters, somewhere like that. Okay. All right. All right, and then different graphs, but you guys know depending on which group you're in, you'll be able to do one of these graphs, right? You got a couple of graphs that are blank that we'll probably have to save for tomorrow, I'm thinking, way it's worked out in past years, right? But there's like a couple of ways you can complete this this lab in the end. Okay? So, for sure. I think I hit all the points I'm gonna make today. You know what? This one's sort of last thing. We do have some new notes for you guys. I might throw these at you guys sometime during class, but we'll get those until like tomorrow probably. All right. Anybody got any questions? Any questions? All right. So let me go ahead and stop this recording. Let you guys do your thing and walk around and help you guys out and see how far you guys get today.